This is the second part of the video for lesson 1-2, measuring segments, and it will include examples 6, 7, 8, and 9. Example 6. In this example, you will use the definition of midpoint. Q is the midpoint of PR. What are the lengths of PQ, QR, and PR? So they want to know the numeric distance or length between these 2 points, and the first and last point. Since Q is the midpoint, we can use the definition of midpoint. So by definition of midpoint, it tells us that the midpoint cuts this PR into two congruent segments, PQ and QR. So by the definition of midpoint, PQ is congruent to QR. By the definition of congruent segments, if two segments are congruent, their lengths are equal. So the length of PQ must equal the length of QR. Once you've established that, then you can substitute in the values for PQ and QR here and here. And it'll result in an equation. So we have PQ, or the length of PQ, is 6x minus 7 equals the length of QR, which is 5x plus 1. Now we use algebra to solve the equation. First thing we do is subtract 5x from both sides of the equation to balance it, giving us just one x term. 6x minus 5x is 1x, or x, minus 7 equals 5x minus 5x gives us 0x, or 0, and then we have a 1 left. Then we add 7 to both sides, and x is equal to 8. Now the problem asks us to find the length of PQ, the length of QR, and the length of PR. So using the value for x, which is 8, we plug those in or substitute them in. So starting with PQ, the length of PQ was 6x minus 7. So substituting in x equal 8, we have 6 times 8 minus 7, which is 48 minus 7, which is 41. So the length of PQ is 41. Then we move over to QR, or the length of QR was equal to 5x plus 1. Substituting in the value for x, we have 5 times x, which is 8, plus 1, which equals 40 plus 1, which equals 41. So QR, the length of QR, is 41, and that should make sense because since Q is the midpoint, these two segments had to be equal in length. Finally, we find the length of PR, which is the entire segment. We can simply use the segment addition postulate. PR was simply PQ plus the length of QR. PQ we found to be 41 plus QR was 41, and that gives us 82. So the length of PR, the whole segment, is 82. In example 7, it asks, or it tells us on a number line, point E is at -5, and the length of EF is 7.5. What are the possible coordinates of F? And this time we're going to use the ruler postulate again, but we're going to use it in a slightly different way. So by the ruler postulate, we have segment EF, the length of EF will equal the absolute value of the difference between those two endpoints' coordinates, E and F. Start off like that. Then we take what we know and substitute it in. We already this time know the length of EF, which is 7.5. So we place it there, equals the absolute value of E, which is -5, minus F is what we're looking for. We're looking for the possible coordinates for F. Now there may be more than one, so keep an open mind. From Algebra 1, when you had an equation where you were trying to find the absolute value of a variable, find out what it was. Let's say we had the absolute value of x equals some number like a. To solve that, we drop the absolute value symbol, and that equals the positive and negative case for that constant value, plus or minus a. So using that pattern or that rule, we come over here, we drop the absolute values here, and now we have -5 minus f, and what it equals is plus or minus 7.5, either the positive case or the negative case. Now we have to solve for f. To do that, we need to get rid of the -5, which means we add 5 to both sides. When we do that, we get 5 plus or minus 7.5 equals, that's 0. We're left with -f. Now, this -f is really -1f. To get rid of -1f, we can divide both sides by -1. When we divide both sides by -1, all the signs for every number changes to its opposite. So this becomes positive f, this becomes -5, and what was positive becomes negative, and what was negative becomes positive. So you still end up with plus or minus, just in the other direction. So f, the coordinate at f can either be, is either at -5 minus 7.5, which is -12.5, or -5 plus 7.5, which is positive 2.5. Here is a number line, a visual completed using this work here. Here's point E, one of the endpoints, and there's two possible other endpoints for F, but they both have to be 7.5 units away from E. So it could have been that F was over here to the left, 7.5 units, at -12.5 or 12.5, or it could have been that E or F was over on the right of point E, 7.5 units, at 2.5 or 2.5. Example 8. Examples 8 and 9 are both constructions. When performing constructions in geometry, always remember that the only tools you should use are a lead compass and a straight edge, or you can use a ruler, but the ruler cannot be, you cannot use the scale on the ruler. You can only use it as a straight edge. So, for example 8, in this example, you'll learn how to construct the segment that's congruent to another segment. Sometimes this is referred to as copying a segment. So, given segment AB, construct segment CD so that that new segment CD is congruent to the old one, AB. So to do this, the first thing we do is we take our compass and we set the compass on A, point A, and we adjust the compass for the length out to the middle of point B, and we draw an arc, ARC, it's called an arc. Keep the setting on your compass exactly like that. Take your straight edge, draw a ray that's longer than segment AB. Just needs to be a little longer. Let the first point be the first point in our new segment, C. Now D we'll get to in a moment. Take your compass, should be set from A to B. Bring the point over to point C, point of the compass, and carefully draw another arc that intersects that ray. Where the intersected arc and ray are, draw point D. You have just created a copy of segment AB and called it CD, where you've repeated it. And that's your answer. So AB, segment AB, is congruent to segment CD. Number 9, and the last construction, you're going to learn how to construct a perpendicular bisector. Now, a perpendicular bisector is going to cross this right at its midpoint at right angles with segment AB. And we're going to do the whole thing without doing any measuring, just a compass and a straight edge. Take your compass, set the point on point A, right in the middle of point A, and set the compass to where it's a little bit longer than halfway between A and B. Draw an arc similar to that intersects AB way up and way down. Keep the setting on your compass. Put the point of your compass over on B and draw 2 more arcs. One that intersects the first arc up here, the other one that intersects the arc down there below. Where these intersect, call them point X and point Y. Take a straight edge, very carefully and accurately line up both points X and Y, draw through them both, and you have just created a perpendicular bisector. We're going to call this point M for midpoint. So you have created perpendicular bisector, line XY, and so AB was bisected by line XY at point M. And this concludes the exercise or the examples for lesson 1-2.